Hello, in this video we'll graph this rational function f of x equal x over x squared minus 4. So the first thing we'll look for is the x-intercept. So for the x-intercept we set y equal to 0, y or f of x equal to 0, and we solve for x. In this case, f of x equals 0 equal x over x squared minus 4. So what value of x makes the rational function equal to 0? Numerator must be equal 0, because when we do 0 over anything equals 0, except that the denominator should not be equal to 0. So in this case, x should be equal to 0. So we have 0, 0 is our x-intercept. And for the y-intercept is the same thing. We're going to set x equals 0 and solve for y. And that is straightforward. F of 0 basically is 0 over negative 4, which is a 0. 0 over any number that is not a 0 equal to 0. And again is the same. 0, 0 is the y-intercept. Is, as we see here from the beginning, that once you have 0, 0, that's going to be an x and y-intercept at the same time. So I'm going to locate this point here, right here, the origin is the x and y-intercept. Now the vertical asymptote, we get the vertical asymptote from the domain, or when the denominator equal to 0. So x squared minus 4 equal to 0 will give me x equal 2 or x equal negative 2. So we'll graph this x equal 2. So we take every unit. This is negative 2 here and 2 here. Every unit is a 1. So this is my vertical asymptote. So right here we have x equal minus 2 and x equal to 2. For the horizontal asymptote, so we have horizontal asymptote here. Since numerator, or this polynomial x divided by x squared minus 4, the other polynomial, is difference by 1, but the numerator is 1 degree less than denominator, then we're gonna have the x-intercept as the x-axis as horizontal asymptote. In another way, if you look at the function, I'll call it y equal x over x squared minus 4. And once x approaches infinity, like 10,000, then you have 10,000 divided by 10,000 squared, which is way bigger value, minus 4. If you try that in a calculator, your y value, your value when x approaches 10,000 will be closer to 0. And the same when you go to negative infinity. When you have x equal negative 10,000, then you square it is going to be positive, and then you have negative 10,000 divided by negative 10,000 squared, it will be closer to a 0 value. Therefore it's going to be closer to y equals 0, which is the x-intercept. So here the horizontal asymptote is y equal 0. I'm sorry, I said x asymptote, or the x-axis, which is y equals 0. X-axis in our case. So I'm gonna write it down here just in red, so we know this is an asymptote, and the function may cross this asymptote in the middle, but as x approaches infinity or negative infinity, it will be an asymptote. The function will be closer and closer to the asymptote, or the line. So here we're gonna try to find some other values that will make us or help us graph this function. So we could choose 1, and we find where is f of 1. So it's gonna give us 1 over a negative 3. So we have 1.1 minus 1/3, and then we could plot a negative 1 as well, and so it's gonna be 1 over negative 1 over again negative 3, which is 1/3. So we have this point 1 and 1/3, negative 1 and 1/3, and then we could choose a point, for example 3, and plug it in 3. We'll have the value of 3 over 5. So here is another point, 3 and 3/5, and maybe f of negative 3 as well. So it's going to give us negative 3/5, and you have negative 3 and negative 3 over 5, and so on. And you may question where I get this point from. So just I see that this point I have, so I want to know how is the function going to look here between these two asymptotes. So I plot check 1, so I get a negative 1/3, which is somewhere here, and then I'm gonna try negative 1 and see how is that gonna be. So negative 1 give us 1/3, which is right here on the positive side. And so I could plot another point, which is negative 1.5, and see what's going to be, and so on. So the graph will look crosses this point, and since this is a vertical asymptote, will look like this. And we could plot another point 3 here, as I saw here, and I will have 3/5 somewhere here. You could plot another point 4, and 4 will give us 1/3. So I have 4 1/3 as a point again, so it's going to be closer and closer. You could plot a point between 2 and 3 and so on, and it's going to give you values positive. So this is an asymptote. And the same here, we could plot a point which is a negative 4, and which is going to give us again negative 4 over 16 minus 4, which is minus 4 over 12, which is negative 1/3. So I have 4 minus 1/3, so it's going to be on the negative side. Negative 4, negative 1/3, this is negative 3, negative 1/3, and you could plot a point negative 3.5 and see how it's gonna go. So the more points, the better the graph is. And I hope this is helpful.